where we have a fraction bar. What you want to do, again, is look at the numerator first and then the denominator. So in the numerator, we notice we have a 2 squared. And then the denominator, we notice we have a 4 squared. We have 16 divided by 8. So we perform that operation, we get 2, and we have 16 divided by 2 in the denominator, and we would get 8. So that gives us 12 minus 4 divided by 10 minus 8 by performing 2 times 6 in the numerator. Finally, we perform the subtraction and then do the division. So we get 4. Several properties of real numbers will make working with them a lot easier. Let's begin with the idea of adding two numbers. If we add 3 plus a negative 7, we get negative 4. And if we switch the order and we get minus 7 plus 3, we also get a negative 4. So we can say that 3 plus a negative 7 is equal to negative 7 plus 3. Turns out we can do the same thing with multiplication. 4 times a negative 2 is a negative 8. And if we switch the order, minus 2 times 4, we also get the same number. So 4 times negative 2 equals negative 2 times 4. So this deals with the order in which you perform the operation, and this is called the commutative property. So the commutative property says for all real numbers a and b, a plus b equals b plus a, and a times b is equal to b times a. Now another property deals with, let's say, adding 3 numbers. Suppose we have these 3 numbers, minus 2 plus 3 plus 5. If we add 3 plus 5 first, we would get 6. And if we add the minus 2 plus 3 first, we also get 6. So we can say that we can add the 3 plus 5 first, or we can add the minus 2 plus 3. Okay, now let's look at this with multiplication. Suppose we have 9 times negative 2 times 5. That's equal to 9 times negative 10, which is negative 90. Suppose we perform the operation in this order. We have 9 times negative 2 times 5, and we also get negative 90. So we can say 9 times negative 2 times 5 is equal to 9 times negative 2 times 5, where we're performing the operations we're performing minus 2 times 5 here first, and 9 times minus 2 here. This is called the associative property. For all real numbers a, b, and c, if we perform the operation first, so we have a plus b, that quantity plus c, that's the same as a plus the quantity b plus c. And the same thing with multiplication. Now let's talk about some identity properties. Notice that if we take 0 plus 2, we get 2, and if we take minus 7 plus 0, we get minus 7. So the number 0 preserves the identity of a number under addition, is called the identity element for addition. Let's look at another operation. If we take 3/5 times 1, we get 3/5, and 1 times a negative 7 equals negative 7. So the number 1, the identity element for multiplication, preserves the identity of a number under multiplication. These are called the identity properties. For every real number a, there exists unique real numbers 0 and 1, such that a plus 0 equals a, and 0 plus a equals a, and a times 1 equals a, and 1 times a equals a. Let's look at this operation. Negative 3 plus 3 equals 0. 4/7 plus a negative 4/7 equals 0. This is called the additive inverse of a number. A plus negative a equals 0. So these are called inverse properties. For every real number a, there exists a unique real number, negative a, such that a plus negative a equals 0, and negative a plus a equals 0. For every non-zero real number a, there exists a unique real number 1 over a, such that a times 1 all over a equals 1, and 1 all over a times a equals 1. For example, 3 times 1/3 equals 1, and 1/3 times 3. Let's look at another property. Suppose we're asked to find the area of this rectangle. we can take the width of the rectangle 2 and multiply it times the sum, 6 plus 3, and get 18. Or we can look at the area of the pink rectangle and add it to the area of the gold rectangle, and we also get 18. So what you can notice about these is called the distributive property of multiplication over addition. For all real numbers a, b, and c, a times the quantity b plus c is equal to ab plus ac. We can look at some more examples of this. Suppose we have the expression 3m plus 36. We can write that as 3m plus 3 times 12, which is 3 times the quantity m plus 12. Another example, suppose we're asked to calculate 2 times the quantity 5t minus 4p plus 1. We multiply 2 times each one of those terms, and we get 10t minus 8p plus 2. Okay, what we've gone over today are some properties of real numbers and some interesting sets of real numbers. You need to become familiar with the terminology because your instructor and your textbook is going to use this terminology throughout the course. So keep practicing on these problems and think about the terminology as you're going through the problems.